engineer will say maybe the electrical system has an issue, battery may be flat. Okay. The Windows engineer will just say maybe you wind all the windows again and try. Of course, shut down, restart the process. Okay. So again, with every of these, there's always a systematic approach. We don't go in and just say, it's not a crystal ball. We don't go in and say this is possible. So what is this systematic approach? Okay. Okay, we also talk about network documentation, and this is something that even myself, when we're in the industry, find a chore to do. Why? Because you finish fighting the battle already. Then you still need the right documentation. It's a chore, but it's necessary evil. What is a general troubleshooting process? Okay, and we use systematic layered approach. What is tools to gather, analyze, symptoms of network loops. Determine symptoms and causes network problems using a layered model and troubleshoot using a layered model. So what is this layered model talking about? Okay, so before you come to that, we will talk about network documentation first. Network documentation is a complete set of accurate and current network documentation. Current. Okay. The challenge here is to have it at current, because when something changes and something changes quite often, how do you ensure it's current? Okay. Configuration files, encoding network configuration files, and end system configuration files. Physical and logical topology and baseline performance level. So, if you're talking about small enterprises, not so difficult. I have maybe 20, 15, 20 switches. Okay, my building, maybe one building, one or two buildings. Alright, then maybe about 200 to 500 PCs. The topology usually don't change. Okay, we'll talk about MMC, how the topology change like every other month. So how are you going to maintain this? Okay, not to mention what is your baseline level. So sometimes, okay, in a big environment, an enterprise environment, you get different engineers at different levels. So you have engineers at the core network level, engineer at the distribution center. Then we have engineers at the edge network, which is by and large the help desk. Okay, so what do we mean by documenting? We have all these things in place. Okay, topology diagrams, physical topology, okay, device type, operating system, connection specification, cabling endpoints. Cabling endpoints is particularly a bug point over here, because you need to know what you have before you can move on to do what you want to do. Okay, as for this lab. Okay, by right there should be a cabling diagram. Okay, where are all the network points? On my table there's a network point. Okay, just last year this table has a few network points also. Okay, so where does this network point go to? Where is it terminated? Okay, so we need to know all this. Right? Not only you need to know all this, you need to know how to shut it down when necessary, or power it on, or we learn about NAC, network access control, how we're going to use these network points. These are the actual network points that we have to do. On top of that, you also study VLAN, okay, which also associates itself to the actual network points. So maybe port 1 to 10 is VLAN 1, port 11 to 20 is VLAN 2. So all these falls under physical topology. Okay? Logical topology, identifier, especially the IP address and prefix length. You don't give me IP address without the subnet mask, then you don't know what kind of IP address it is. Connection type, okay, side-to-side VPN, circuits, these are the older ones. Okay, routing protocols, you OSPF, okay, or your static routes. Most likely it's a static route you need to know, because OSPF is quite dynamic. You cannot tie down to one route. And what is the one technology used? Okay, so we covered ISDN, we covered frame and day ATM, we covered broadband. Okay, what is the technologies we use? Okay, so what is a baseline? Before we talk about network baseline, what is a baseline? It's usually what we call a normal operating standards, operating environment. use a very simple example. What is the baseline for normal human temperature? Anything from 36.5 to 37.4, right? What's the normal? Okay, what is considered a fever? 37.5 and above. That's the fever. So our baseline is between 36.5 to 37.4. This is our normal operating temperature. Okay, so once you hit 37.5, you know of fever, something wrong. Same for the network. What is the network performance on the average day? So the keyword here is average day. I cannot just take one. Oh, I want to measure my baseline of my ID network. I take it at 8 p.m. at night. Nobody is using, of course, the battery is very good. Okay, but do I only take one reading? No, typically baseline we take across maybe a couple of weeks. Okay, okay. So because why? Even in ITE, let's say you do baseline reading, start of the term very high usage. Towards the end of the term, very low usage. Why? Students are overstudying and so so forth. Towards the term break, no usage. Why? Nobody around to use it. Right. So, how does network performance on a normal and average day? What are the most errors occurring? Okay, run out IP address, so and so forth. Okay, what are the alert threshold that is set for devices that to be monitored? So I have edge devices here, for example, my wireless. If my wireless bandwidth is over D, I need to monitor it. Okay, can the network meet the identified policies? ECL is it there? Which part of the network is most heavily used? So in ITE, which part of the network do you think is most heavily used?
School network.
Yeah, this school network for students. Which part do you think is most heavily used?
Wi-Fi.
The Wi-Fi is the network we use. How about the choke points? Or go to internet. So all the traffic go through my internet. My choke point is my internet. And you're right, Wi-Fi. Correct. Wi-Fi is very heavily used. You do see students taking cable and plugging in. Okay. Which part of the network is least used? Your cable lah. Your cable. Okay, but is it necessary to be there? Yes. Yes. It's necessary to be there. Alright? So this, okay, the network baseline determines the personality of the network under normal conditions. So we can establish this is your normal conditions. But the problem with this is that your normal conditions, when your network is very fluid, very versatile, your normal may change a lot of times. Okay? So, but if a more established enterprise or a company which there's less fluidity, then maybe you can establish a much nicer looking normal environment. Okay? So first thing is this. At least for networking also, for this, but it can be used for demonstration. Then what is your server baseline? How much CPU usage we use? What is the RAM we use? What's the hard disk capacity we use? What is the network card capacity we use? That's your baseline for the server also. Same logic applies there and everywhere you top of baseline. What are you going to collect? Okay, what are the ports of interest and how long you collect? Okay, so how long you collect also determines on environment. I still collect half a year info for ITE, no use, because every term changes, the traffic will fluctuates. So you must know your environment. Okay, I take one term. Okay, then we take another term. Then we take these two terms and check the baseline, are they the same? You take the whole semester, that means 2 terms, then you realize that it may not be very useful. Right? Okay, measuring data, commands that are useful are your, these are the ones you know already. Yeah? Ping. How useful is ping? Ping has timeout and all this and time delay. Telnet. Okay, how you going to access your router switches via the virtual terminal. Okay, interface brief, what is being connected. Okay, IP route. Okay, what is the routes that has been connected by a static. By a static. Okay, this is the general troubleshooting process. What is the system? Like go to doctor, you sit down, doctor say, good evening, Mr. Bo. what is your problem today? What can I do for you today? Where you in pain? So you gather symptoms, then isolate problem. Oh, you have headache, you have a fever, so try to isolate the problem. Okay, implement corrective action. Okay, for our students, it will be, oh, you look sick, maybe 3-day-MC. Wow, the problem all solved already. Right? But in this case, of course, you try to get we see a doctor for a real reason, correct? Because doctors are not cheap. Okay. So is the problem fixed? Yes or no? So we will do again, come back here, problem fixed, correct? So we always forget this, document changes. Document changes, we always forget this. So this is a general troubleshooting procedures. Okay, so how we going to gather symptoms all here? Okay, all the commands that gather the symptoms. Okay, I usually use this. Okay, if I never reach my gateway, I know something is wrong with me. If I can reach my gateway, then I use trace route. Right? So they can reach my other gateway. Okay? Then we can see if I have access to my telnet to go in on SSH, then I see my routes. Okay, then I see my right config. Then if really all fail, then we open debug and see. Okay, debug means set your debugging level to 7, 8, 9, that information set of 9. You set it there, then every single thing the router goes through, it will show you on the screen. The debugging. What the problem is, if you turn it on for a long time, your CPU cycle will use a router will be very slow. Okay, so questioning end users, what works, what does not work? Ask the questions as pertinent to the problem. Okay, use each question as means to answer or discover possible problems. Speak at the level the user can understand. When it was first noticed, anything unusual, can you recreate, determine the sequence. Do you realize these are the questions the people ask when you call a help desk, helpline, IT help desk? Correct? Is this the first time you face this problem? Have you tried this? Is this working? Oh, very big check already, you know.
They always ask to restart.
Yes.
I restart, still the same.
Yes, I restart still the same. I tell you this very interesting thing. You all know I worked in a Japanese company before. So this finance director, fresh from Japan, came to Singapore to work. Okay? It was a very long time ago. Nobody uses Wi-Fi, uses cables still. So every table has a cable there. Okay? So this director called me, expecting English. Vincent's network. No, have. Can check. Director, I come down. So I come down and ask him, before I do anything, I ask him, do you plug in cable? Yes. On power? Yes. Do this? Yes, very yes. Then check. Looks as if he's doing correctly. Then I realize he plugged the telephone cable to the network cable, the network cable to the telephone cable. Yes. All plugged in, all wrong. Yeah. So even you ask all these questions, we actually have to go there and see. So in this case, I was lucky to go and see, I get a complaint and a story for me lah. Okay. But these are things, especially when I call M1 when my router is not working. They ask me so much question. I tell you, just skip to the end. Okay, whatever you ask, I done with it. Okay. Just tell me whether can you see my router at your side. Yes. Okay, that's enough. That's my problem and no story. You know, I spent 20 minutes waiting to talk to the fella. Another 10 minutes telling to yes, yes, no, yes, no, yes, no, yes, no. In the end, my problem still. Right. So this is what happens. How to question end users. Okay. And this is a skill. This is a skill. SKILL to question end users. Now, what is a layered model? Talk about layered model. So we're using the OSI layer model. Okay, got 7 layers. How are we going to talk about using the layered model for troubleshooting? Okay, so this is usually when you are first new to this and you are trying to troubleshoot a problem which is new to you and it's not documented. So now you can see documentation very important, right? Okay. Also nowadays documentation is not very useful. Why? Because you can just Google the problem. Half the world tell you the problem. You cannot Google, never mind, ChatGPT can tell you also. Okay? So, but all this takes time. If you know how to explore, be much better. So these are the layer models. So we need to know what is the OSI, application, presentation, session, transport, network link, and physical. So how do we go about doing this? Okay? There's 3 ways of doing this, and these are potential exam questions, especially short answers or long answers. You actually write down, explain to you why you use this method. So given this, which method should you use? Which method is recommended you use? Okay, bottom up. Bottom up, as the name suggests, they start from the physical layer upwards. Okay, so the first question asks, can you access the internet? Cannot. Do you see a light blinking behind your computer or network card? Don't have. Bottom up already. You're checking the network cable. Right. Next thing is top down. Can you access the internet? Cannot, but I cannot access Office web page. Can you access this page? Can you access that page? Top down approach. Why? I'm assessing whether is this the problem with the page or is it a problem with our DNS system? Or is it a problem with the systems that's cached in the person's computer? Next question I will ask is, can your colleague beside you access? Can or cannot? Cannot means everybody can access. Okay, so it's top down. Divide and conquer is I start from bottom. Can you open and ping this server? I start from the middle already. Can you ping my server? How to do it? You open command prompt, cmd, type png, ping this. What do you see? Request timeout. Divide and conquer. Request timeout means go down already, right? Because bottom cannot access it, my IP address not there, or maybe my cable not connected. Okay, but if I ping, reply, have, then I from middle I go upwards already. I know my network problem, no issue, my IP address, no issue already. So from there I move upwards. So this is what I call a divide and conquer method. Okay. Less structured troubleshooting methods would be educated guess based on the symptoms of problem. Cannot pick only 2 problems. Okay, either network not connected, either Wi-Fi or cable, or no IP address. Okay, so these are the things. Educated guess. Compare working and non-working situations, spotting significant difference. Your colleague beside you can use can print cannot. Then you compare, or can print, or means you use this PC problem. Okay, swap a problematic device when non-working set is put you on troubleshoot. Okay, not everybody has the luxury of having a router lying around everywhere. Okay, for those who drive, you know that if the PC, if your car vehicle is down, your mechanic say, hey, I think it's the alternator. Change. Still cannot. I think it's the fuel pump. Change. Still cannot. I think what I tell you, the bill will go sky high because our friend keeps swapping. Yeah, it's my house. Somebody is opening my door.
You never see
I can see if I want to. Yeah, but there's people at home, so it's okay. Okay. So these are the less structured troubleshooting approaches. Okay. So what is the guidelines for choosing the troubleshooting method? Okay, if you have experienced before, okay, divide and conquer, or with new problems, typically we use the bottom method. If it's complex, we use the bottom method. Okay, the scope of the problem is very limited. Okay, top down. What do you mean limited? Oh, my colleague can access the Google, but I cannot. limited, right? So top down lah. Okay. Or complex, or some of us can, some of us cannot. Sometimes can print, sometimes cannot. Oh, you don't know what's happening in it. Very complex bottom up. Start from the bottom, network connectivity. Okay, so you analyze the problem and you choose. Okay, so this is a very important slide. I think came out in 2 exam papers before. It may come out again. Okay, how do you select the thing? Okay, this is guidelines. Okay, this is based on the knowledge that you are not an experienced administrator, an experienced IT professional. Alright? Okay, network troubleshooting. Okay, some of the more common software troubleshooting tools include NMS, network management software tools, knowledge base, baselining tools, host-based protocol analyzer, and I have no idea what is this. So we will cover this. Okay, so network analysis module, digital multimeter, cable tester, cable analyzer, portable network analyzers. So, of course, this is pure physical. Pure physical, we go and test the voltage. Why we have digital multimeter? Okay, this is more of a legacy thing. Okay, sometimes your cable is shared by another line, your telephone lines. You check the voltage, so on and so forth. And we're talking about token ring topology. We need to know the voltage also. Okay, we actually have a cable analyzer type of module. If you have an opportunity to go and look at this Fluke network cable analyzer. Okay, you plug it in, it can tell you what's the IP address, what's your speed, what's your noise level, what's the DB level, what is the protocol running. Everything that's running on cable, this thing can check. So this is a hardware cable analyzers, portable network analyzers. Alright. Now of course we use this log for troubleshooting. Okay, if we receive a higher level, you can see what is the error. And with the logs we have description also, correct? They also can decipher what is the description. Okay, so physical layer troubleshooting, start from bottom up, look at the systems. Low performance lower at baseline, loss of connectivity, okay, network congestion or bottlenecks, high CPU usage, console error. You'll be surprised, very mundane things like the cable being bitten off by a rat is also possible. Okay, I have many cables bitten off by rats before. Okay. Hardware power related, hardware faults, cabling faults, attenuation, cable too long, too close to other power line, your wireless module, too many metal structures around, your signal very degraded. Okay, interface configuration error. Okay, over there you're supposed to be using 1 gigabit. Over here you set it to 100 megabits. It will connect, but will have a lot of errors. Okay, but a lot of errors. Alright. So we have this data link layer. Okay, again we got encapsulation errors, network mapping errors, okay, framing errors, or STP failure loops. Okay, so I also had this problem before. STP, spanning tree protocol failure, where some birdie take a cable from port 1 plug to port 5, plug to itself. Okay, STP loops, the network go looping. Okay, what happens? It's finding itself, right? So your frame gets flooded. Eventually your switch go down. Okay, but okay, nowadays we use STP, entry protocol, to prevent this. So once it detects a loop, it will block the port. Okay, so this is what happens. Right, of course, network layer IP address, they will issue troubleshoot, what's it called? Topology, routing tables. Okay, so the network layer. Transport layer got ACLs. Why ACL is transport layer? Because ACL has port numbers, extended ACLs, port numbers, start of protocol, TCP, UDP, ICMP, okay, your mask, okay, your established keywords. What is established keyword? Established keyword is only when the connection is established, then you allow it through. What do I mean by that? For example, I'm a client, I want to go to the server. Okay, I'll make a request to the server, please show me your web page. This is a connection out. Server will then reply you the web page. So there is a two-way communication. Okay, but if I did not make a request but the server still sent to me, then it violates the established keyword because there's no establishment of session. So it's a scammer calling you. Right? So this is under the transport layer. Okay, uncommon protocols. Some of the protocols we use are quite uncommon. Quite notably, if you use peer-to-peer file sharing, they use a lot of ports. Okay, it may happen to run into some of the monoports and you have port conflicts as well. Okay, transport layer we have got DHCP, DNS, VINs, okay, NAT, because we use a lot of sessions in there. Application layer with all these whole part here for this. Okay, so one of the easier way to understand is your DNS. DNS. If your DNS is not working, I am still able to access my site by IP address. Right? Okay, some of the components of troubleshooting for end-to-end connectivity cannot ping, check cable, check for duplex mismatch. That's why you say in your networking, leave it to auto, it will automatically set it itself. You manually set it, there is a chance that it may not be a correct match, as well as your ARP, MAC address table, and VLAN assignment. Especially VLAN assignment. Okay, you have got the wrong port. You all know yourself, right? You all configure VLAN, got the wrong port, can access it. Gateway, okay, is your gateway correct? Okay, routing is it correct? Okay, we have not covered this, but in your PC, you can also set multiple gateways, multiple routing. You can even set static route in your PC. How do you think your VPN works? Let me draw you a diagram here. So, this is your router at home. This is the internet. Okay, then it is you. So your gateway is obviously this one, correct? Okay, what do you mean an alternative gateway? So you create a VPN tunnel from here to here. So effectively, you change your gateway, correct? Because you move all your packets into this tunnel, you move this way. But this tunnel still goes to this gateway because it's encrypted, that's why you cannot see. So there's actually two gateways. So we can actually what we call, in VPN we can do what we call split tunneling. Okay, I want to have this traffic to go through this tunnel. In my routing table, I have this tunnel only. Okay, but I want to have my other traffic to not go through this tunnel and move it to my other traffic, another route to this. Okay, so this is split tunneling. So make sure that your routing table is done correctly. Okay, there's no ECL. This is a common mistake a lot of people do. Hey, got ECL, you must test whether it works or not. What should we do? No ECL. Let's say your floodgate opens, everybody come in. Okay? So, unfortunately, there's no easy way to test ECL except to go through it one by one and look at the logs one by one. Okay, and DNS. DNS. Okay? IP connectivity, check the lights, this is physical. Alright? Duplex. Okay? Half duplex not common anymore. Okay? Then you can see IP routes, verify the default gateway, have or not. Okay? Or you can just do your IAP config. IP config and COT for gateway. Right? Use the trace route to check the path taken by packets. Sometimes you cannot trace all the way, but at least we know it's going out. Okay? Going out. Okay? Verify transport layer. Verify ACL. Okay, this is not a good way to do. Even temporary, this is what the hackers want you to do. They wait for you patiently, like those lions patiently waiting for its prey. The moment you bring down your ACL, they come in. They come in very fast, the back door come out, okay? Okay, because your ACL is so many, you can tell. You can tell, huh? Okay, verify DNS. Okay, so again, see, this slide show 2 times correct. Determine the scope of problem. Is it limited, top down, complex, bottom up? Analyze the symptoms. Apply previous experience. The problem start from bottom. Experiment involve divide and conquer. Right? Any questions? Any questions? This concludes all our theory slides for your exams. These 2 slides are not very heavy, quite light actually. Things that are more common sense. Don't try to overthink things, it's all about common sense. Don't try to overthink things, all about common sense. Okay. Some administrative things to do. So again, for those who just came in, just not miss this. Okay. We have covered this already, so this completes all our topics. We still got 3 more lessons, 3 lessons. I know you have 2 more with Mr. So. One is this Wednesday and one is the next Wednesday. Okay. So next week 19. Next week no class. Next week is public holiday. Okay, 19 will HBO. We will cover the exam paper. Okay, 26 we also HBO cover exam paper. We need to go to exam paper, I say WhatsApp group already. Okay, so don't come up, we do online. Right? Then 28 SDLs of the make anything, it does let me know what else you think we need to cover the lesson. Okay. As I explained this class was just now, I also want the HBL, but no, sometimes it's beyond my